Okay, so today we're diving headfirst into object-oriented design patterns, which, I'll be honest, sounds a little intimidating.
Yeah, it's a mouthful for sure.
Thankfully, we've got two heavy hitters in our corner. The infamous Gang of Four book.
Ah,
Yeah,
yes, the Design Patterns Bible.
exactly. Alongside the slightly less intense design patterns for dummies. You know, just to make sure we're all caught up.
No one's judging these patterns. They're like the secret sauce for writing really good, clean code, whether you're just starting out or you've been coding since, well,
Since before these patterns even existed.
maybe. But seriously, understanding them is a game changer.
All right, before we get too far, let's clarify something for our listeners. When we say design patterns, we're not talking about, like, literal blueprints for software, right?
Not in the literal sense. Think of them more as proven solutions to common problems you bump into in object-oriented programming.
Okay, so instead of reinventing the wheel every time, we can pull out these pre-designed solutions.
Precisely. It's all about working smarter, not harder. And this is where our Gang of Four comes in. They basically created a catalog of these patterns, 23 to be exact. These have become essential knowledge for any serious developer.
23. Okay, so maybe we won't cover them all today,
Probably not.
but we can at least sample a few, right? Just to give everyone a taste.
Absolutely. Let's start with, the adapter pattern. Imagine you have two systems that need to talk to each other, but they weren't designed to. Kind of like trying to fit a square peg in a round hole.
I've been there, usually with some colorful language involved.
Well, the adapter pattern is like that magical adapter you find in the back of the drawer. It bridges the gap, letting
Yeah.
those two incompatible interfaces communicate.
I'm already feeling less frustrated.
Oh.
Okay, now for a pattern that's been on my mind, the strategy pattern. Does it involve, like, miniature algorithms having a foot race?
Kind of. It's about having different algorithms at the ready and choosing the best one on the fly, depending on the situation. Adaptability is key.
Okay, I can see the appeal in that. Can you give us an example, though?
Sure. Imagine you're coding a navigation app. You wouldn't use the same algorithm for someone driving a car as you would for someone on a bike, right?
Right. You'd want to factor in things like traffic, bike paths.
Exactly. The strategy pattern lets you seamlessly switch between those different algorithms depending on the user's needs.
Okay, that's pretty slick.
Mhm.
And it really drives home that these patterns are solving real-world problems.
Exactly. And that's what makes them so valuable.
Speaking of valuable, we can't forget about the decorator pattern. It always sounds a bit too delicious for software design, doesn't it?
Right. It's like adding toppings to a pizza.
Okay, I'm listening.
You start with a basic object, your plain pizza, and then you can layer on new functionalities without changing the core object itself.
So I don't have to create a whole new pizza from scratch every time I want to add mushrooms or pepperoni.
Exactly.
Yeah.
Each topping is a separate module, making your code super flexible. You can add or remove them as needed without messing up the whole pizza.
Now that's a programming style I can get behind. But what about when you need to make sure there's only one of something? Like in those epic fantasy books, there can only be one ring.
You're thinking of the singleton pattern. This one guarantees you'll only ever have one instance of a particular class in your entire application.
So no matter how many times someone tries to create a new one ring, they'll get the same one.
That's the idea. It's super helpful for things like database connections or, in your example, a really powerful magical artifact.
That's a design pattern I wouldn't mind getting my hands on.
Mhm.
But we've thrown a lot of patterns at our listeners. Can we take a step back and talk about why this approach is so beneficial?
Of course. One of the biggest advantages is that it improves communication between developers. It's like we all suddenly have this shared vocabulary.
So less lost in translation moments when everyone's on the same page.
Exactly. And that means fewer errors and misunderstandings. Everyone wins.
Fewer errors, that's music to any programmer's ears. But it sounds like it goes deeper than just communication, right?
You're right. Design patterns make your code incredibly robust and flexible. Plus, because these patterns are so well established, you're less likely to introduce bugs from the get-go.
So it's like future-proofing your code. You're not just building for today, but for whatever crazy requirements pop up down the line.
Exactly. It's about building software that can evolve and adapt.
And that is incredibly fascinating. It's not just about making code work, it's about making it work well. Speaking of which, we got a lot more to unpack.
Oh yeah, this is just the tip of the iceberg.
Up next, we're going even deeper into design pattern territory, starting with the mysterious and alluring factory pattern.
Now that one's a real game changer.
Well, listeners, you won't want to miss this. We're about to get our hands dirty with some serious coding philosophy.
So the factory pattern, it's, well, think of it like a well-oiled machine for creating objects in your code. You're not building every single object by hand. You've got this system that handles the process for you.
Okay, I like where this is going. But can we make this machine a little less abstract? How would it actually work in, the real world of coding?
All right, picture this. You're building a video game. You need to create all sorts of enemies, right? Goblins, trolls, dragons, each with their own unique quirks and
That
abilities.
sounds like a lot of code to keep track of.
It can be, but instead of writing separate creation logic for each one, you use a factory.
So the factory is like a central hub that churns out all these different enemy types on demand.
You got it. You tell the factory, give me a goblin, or I need a dragon over here, and it handles all the details, spitting out a fully formed enemy object ready to wreak havoc in your game.
That's way more efficient than anything I've ever tried. But we're talking more than just clean code here, right?
Yeah.
What are the real advantages of using a factory pattern?
Well, for one thing, it keeps your code nice and loosely coupled. Your code isn't as dependent on the specifics of how those enemies are built, which makes it way easier to maintain down the line.
So if I decide to, say, give my goblins an upgrade, I wouldn't have to rewrite every single instance where a goblin is created.
Exactly. You just tweak the factory and you're good to go. It's a lifesaver when you're dealing with large, complex projects.
That's a serious time saver.
Yeah.
But I have to admit, this whole factory thing still feels a little abstract to me. Is there, like, a distinction between the general concept and how it's actually implemented?
Good point. That's where you get into the weeds of abstract factories versus concrete factories. An abstract factory is like the blueprint that defines the rules of the game. Concrete factories are the actual implementations that create the objects.
So the abstract factory is like the factory manager, and the concrete factories are the workers on the assembly line.
Perfect analogy. It's a powerful way to introduce structure and flexibility into how you create objects.
Okay, factories check. But our deep dive outline also mentioned something about a command pattern. That sounds kind of, well, authoritative.
Maybe a little, but it's all about control. The command pattern lets you package requests or actions as objects in your code. So instead of directly executing a command, you're creating a little object that represents that command.
Okay, now you've really piqued my curiosity. Got any real-world examples for me? My brain needs something concrete to latch onto.
All right, imagine you're building a text editor. Every action a user takes, typing a letter, deleting a word, highlighting text for them, those can all be represented as command objects.
So each command object is basically a little package of code that knows how to perform a specific action.
Precisely. And the beauty is it separates the thing that triggers the command from the thing that actually carries it out. Your text editor doesn't need to know how each action is implemented. It just tells the appropriate command object to do its thing.
Okay, I'm starting to see the elegance in that. Everything stays neatly organized.
Exactly. And it gets even cooler. Think about features like undo and redo. With the command pattern, these become way easier to implement because you're essentially keeping a history of command objects. You can just step back or forward through the list.
So hitting undo is like telling the program to rewind the last command.
You got it. It's a really elegant way to solve what could otherwise be a pretty complex programming problem.
This is giving me a whole new level of appreciation for the power of patterns, but I feel like we're also starting to touch on some of the core principles of object-oriented programming itself. What about inheritance? I feel like that's a big one.
It's huge. Inheritance lets us create these hierarchies of classes where child classes inherit properties and methods from parent classes. It's all about reusability and avoiding redundancy in our code.
So it's like a family tree for code where each generation inherits traits from the one before it?
Exactly. You can have a parent class called vehicle with properties like speed and color and methods like accelerate and brake. Then you could have child classes like car, motorcycle, and bicycle that inherit those basic properties and methods but also have their own specializations.
So a car might have a change gear method, while a bicycle has a ring bell method, but they both still share that core vehicle DNA.
Exactly. It's a powerful way to model real-world relationships and make your code base more organized. But, like with any powerful tool, you have to be careful not to overuse it.
Ah, so there are downsides to this inheritance thing.
There can be. Too much inheritance can lead to what we call tight coupling, where your classes become too dependent on each other. That can make your code harder to maintain and modify later on.
Tight coupling, that doesn't sound like a good thing. So what's the alternative when inheritance gets too risky?
That's where object composition comes in. Instead of inheriting from a parent class, you create objects that contain other objects as components, assembling functionality like building blocks.
So instead of a car being a type of vehicle, it would have its own engine object, wheel objects, and so on.
Precisely. It's a more flexible approach, especially for complex systems. It's about moving from an is a relationship to a has a relationship.
Right. A car has an engine. It's not inherently a type of engine itself. That makes a lot of sense. But how do you decide which approach to use? When is it better to stick with inheritance, and when should you embrace this whole composition thing? So last time we were grappling with this idea of inheritance versus composition. It's like choosing the right tool from the toolbox, right? When you're building out your code, how do you know which path to take?
It's a question that sparked many a late-night coding debate, but there's a saying in the software world: favor composition over inheritance.
Catchy. But does that mean inheritance is always a bad idea?
Not necessarily, but it's easy to overuse. Think of it this way. Inheritance can create these really tight bonds between classes, which isn't always a good thing. Composition keeps things more, well, compartmentalized. If one part of your code changes, it's less likely to cause a domino effect of breakages.
Okay, so it's about damage control. I can get behind that.
Yeah.
But I'm sure there are still cases where inheritance makes sense, right?
Absolutely. If you have a clear hierarchy where the child classes are really just specialized versions of the parent class, then inheritance can be a good fit. But it's always worth asking yourself, am I forcing this is a relationship, or would a has a relationship be more accurate, more flexible?
Right. Is-a versus has-a. It's like choosing the relationship that best reflects like the actual nature of the objects you're dealing with. Speaking of relationships, we haven't talked about encapsulation yet, which honestly makes me think of preserving something precious like those ancient scrolls you hear about.
Well, there's a parallel there. Encapsulation is all about bundling data and the methods that work on that data together within a class. It's about creating a protective barrier around the internal workings of an object.
So less about time travel, more about imposing order.
Exactly. Encapsulation helps prevent unintended side effects. By controlling access to an object's internal state, you reduce the risk of one part of your code messing things up for another.
It's like each object has its own set of boundaries, right, to keep things running smoothly.
Precisely. And if you want to see encapsulation in action, look no further than the iterator pattern.
Ah, the iterator pattern. It sounds like it involved these little code robots diligently sorting through my data.
Not robots, but close. Imagine you have a collection of items, like a list of names or a playlist of songs. The iterator pattern provides a standardized way to go through those items without you needing to know how the collection is structured under the hood.
So it's like having a universal remote control. I don't need to know the specifics of each device. A road handles it.
Exactly. Whether your data is in an array, a linked list, or a more complex structure, the iterator pattern gives you a consistent interface for accessing each element.
Okay, that's super handy. But are there different kinds of iterators? We came across something about internal and external iterators.
You're right, it's not one size fits all. Think of an external iterator as giving you, the programmer, more direct control. You decide when to move to the next element.
So if I need to do something tricky or conditional while I'm iterating, an external iterator gives me that flexibility.
Exactly. An internal iterator, on the other hand, is more hands-off. You define what you want to do to each element, and the iterator takes care of the rest.
So it's like setting up a chain reaction.
A good way to put it. It can be more efficient for simple tasks.
Options are always good, I guess. Now, stepping back and looking at all these patterns, it seems like a lot of them are about, well, preventing disasters. Like creating code that's less likely to crumble under pressure.
That's a great observation. Design patterns are all about creating more robust, maintainable software. They embody best practices, tried and tested over time.
It's like having a team of senior developers whispering in your ear as you code, guiding you towards better design.
I like that. And one of the key things that'd be whispering is loose coupling, which, again, is this idea of reducing dependencies in your code.
So if one part of the code changes, it's not going to bring the whole house down.
Exactly. Loose coupling helps isolate the impact of those changes.
Loose coupling, encapsulation, composition. These are starting to sound less like programming jargon and more like life advice.
Maybe there's a lesson in there somewhere.
I'm sure there is. Now, before we wrap up our design pattern deep dive, we have one more to uncover: the observer pattern. That name always reminds me of spy movies for some reason.
It does have a bit of an air of mystery. The observer pattern is all about setting up relationships between objects, where one object, the subject, automatically lets other objects, the observers, know when its state changes.
Like a subscription service for code.
Exactly. The observers subscribe to the subject and get notified whenever something interesting happens.
Okay, that's pretty cool. Let's say I'm building a social media app. How would this work in practice?
Well, imagine you have a post object. Every time someone comments on it, likes it, or shares it, the post object can automatically notify its observers.
So other users would get real-time updates without any direct connection between them.
Exactly. The observer pattern is a really elegant way to create these kinds of dynamic relationships in your code.
That's super powerful. It's like building a network effect right into your software.
It's all about creating a more responsive, flexible system.
I gotta say, my mind is officially blown by the sheer elegance of all these patterns. We just dipped our toes in the water, but I could already see how essential they are for any serious programmer.
And this is just the tip of the iceberg. There are so many more patterns to discover, each with its own unique strengths.
So for our listeners who are feeling inspired to dive deeper, where would you point them?
Well, you can't go wrong with the classics. The Gang of Four book is still incredibly relevant. Headfirst Design Patterns is another good one, very approachable. And of course, the internet is overflowing with resources.
The learning journey never ends, does it? That's what makes this field so exciting.
It does. As developers, we get to be lifelong learners, always searching for those elegant, efficient solutions. And design patterns, they give us a fantastic starting point.
Well said. A huge thank you to our expert for guiding us through this fascinating landscape. And to our listeners, remember the journey of 1,000 lines of code begins with a single, well-chosen design pattern. Until next time.